Okay, so this video is about various properties of triangles. We're going to talk about a lot of stuff here, and some different parts of triangles. The first rule, and most of us should know this already, but the sum of the angles in a triangle is 180. Okay, so that shouldn't be too bad. You just got to know that. All right, keep that in mind. Somewhere in your notes, write this, because I forgot to include this. All right. Scalene, a scalene triangle means no sides are congruent. Isosceles, which we're about to talk about, means two sides are congruent. And then equilateral, all three sides are congruent. Now, that's how you name a triangle by its sides. Now, if we were to name a triangle by its angles, an acute triangle, all three angles are acute. So it would look something like that. Okay? An obtuse triangle, one angle is obtuse. So it will look something like this. Okay, you see the obtuse angle right there. And then obviously a right triangle has a right angle. We all know what that looks like. We've been dealing with right triangles forever. Okay? All right? So somewhere in your notes, get that, because that's really important. I forgot to include that. All right, let's talk about isosceles triangle. Isosceles triangle is a single triangle where two sides are congruent, which are called legs, and the two angles across from those congruent sides are also congruent, called base angles. So here's what it looks like. Let's see if I can draw a good triangle here. It's important that you draw one too. Okay? So we'll call this A, B, C. All right? Now, two sides are congruent. All right? And each one of those things, or each one of those sides, is called a leg. And then the two angles across from those congruent sides are also congruent. So there they are. Now, that's called a base angle. That's called a base angle. Now, you're probably like, okay, well, that's great, but what about the base? Well, if these two sides are legs, this is the base. Okay? Now, these two angles at the bottom are base angles. Well, what does that mean for this angle right here? Well, that's called the vertex angle. Okay, so that's the angle that's not congruent. All right? So let's summarize. AB is congruent to AC. Okay, right there. And then angle B is congruent to angle C. Right there. All right? So those are, or that is, an isosceles triangle. That's all the basics. Okay? All right, now let's talk about a midsegment. Midsegment of a triangle. What does that mean? It's a segment inside of a triangle that connects two opposite sides at their midpoints. That segment is parallel to the third side of the triangle and also half of its length. Holy moly, is that a lot of words. All right, Habit, how are you going to translate this? Well, let's see. Let's make a nice triangle. Take your time and draw a nice triangle, okay? The better your diagram is, the more likely it is you're going to understand what's going on. Okay. So segment inside of a triangle that connects two opposite sides at their midpoints. So let's look at this point here and that point there. Now, if those are midpoints, that means that those are congruent and those are congruent. Okay, let me see here. Let's name this D, E, F. And then let's give these points names. So let's give this point G, and let's give this point H. And we're going to connect those two midpoints. Okay? So, in this case, GH is a midsegment. Hang on a second. Okay? It connects the midpoints of two opposite sides. Now, it says that segment is parallel to the third side. Okay? So, in this situation, the third side is EF. So, GH, the midsegment, is parallel to the third side, EF. Okay? Now, it's also half its length. So, and GH is 1/2 times the length of EF. Okay? Now, that's just one midsegment. Okay? A triangle can have 3 midsegments because there's 3 sides of a triangle. So let's make a note of that. Hang on a second. I don't want to say can. It does. Hang on. Whoops. Every triangle has 3 midsegments. Now, let's take a look. So GH is 1. Well, what if I made that point there? We'll call it I. And let's say that was the midpoint. Okay, now by the way, you have these two congruent, these two congruent, these congruent. All right, so what if I connected, whoops. Hang on. What if I connected those two? G and I are midpoints, right? So, GI is a midsegment. Now, in this case, the third side is DF. So the third side is DF. So, what does that mean? That means that GI, the midsegment, is parallel to DF, and the length of GI is half the length of DF. Okay? So same rules, just a different midsegment. Now, the last one. Well, there's only one more. We got to connect I and H. Okay? So, IH is a midsegment. Okay? Now, in this case, the third side is DE. So DE is the third side. Excuse me. So here's what we have. IH is parallel to DE, and the length of IH is half the length of DE. So every triangle has 3 midsegments. They can occur anywhere inside the triangle as long as they connect the midpoints. Okay? And you need to have these marks. Okay? If you don't have those marks, you don't have a midpoint, which means you don't have a midsegment. Okay? All right, median. A median of a triangle is a segment in a triangle that connects a vertex of the triangle to the midpoint of the opposite side. A triangle can have 3 medians, one starting at each vertex. The point inside the triangle where the 3 medians meet is called the centroid. All right, let's draw a picture for that. Again, let's make a nice triangle. This video is long, so I apologize, but we're getting a lot of information. All right, let's call this MNO. Okay, so if I have a median, it connects a vertex. Vertex is a corner point of the triangle. So let's say we start at M. Okay? M is a vertex. It's a corner point. Now, we'll call this P. P is the midpoint of NO because, so how about we say this? P is a midpoint. So that means that NP is congruent to PO. All right. So if I start at M and I just draw this segment to P, that means that MP, that's a P, is a median. Okay? So there's an example of a median. Now, if I were to draw the other ones, so let's say I started at N. So if I have a midpoint here, we'll call it Q. And we draw a segment from N to the midpoint Q. Okay, so Q is a midpoint. So MQ is congruent to QO, and that makes NQ a median. All right. And then there's one more. Obviously, we haven't used O yet. So we'll come over here. We'll call this R. So R is a midpoint. And we connect those. So R is the midpoint. So that means that NR, that's an S, so NR is congruent to RM. And then that means that OR is a median. Now, what is this centroid they're talking about? Well, here's the point right here where all the medians intersect. Okay? We'll call that X. Okay? So what that means is X, actually, let's do it this way. So point X is the centroid. Okay? So Every triangle has 3 midsegments. Every triangle has 3 medians. Okay. Again, this video is fairly long. I apologize, but there's a lot of information, and there's only one video for it. So there's median. All right, we're almost there. Perpendicular bisector. Okay. All right. Well, let's think about what this means. It's perpendicular bisector, so it's a segment that is perpendicular to another segment and cuts it in half. Well, let's think about this. Perpendicular. What does that mean? Okay, first of all, that's the symbol. Second, it makes right angles. So we know that. Bisector means cut in half. Okay, so could I draw a picture that makes that happen? All right, well, so if I've got, let's see how straight I can make this. So if I've got WV, okay, and now I've got this segment here, call it XY. So they're perpendicular, and then there, we'll call this point in the middle, we'll call that Z. So here's what this picture means. So WV is the perpendicular bisector of XY. Okay, so in other words, WV is perpendicular, and then it takes XY and it cuts it in half. Okay, so XZ is congruent to ZY. All right, that's a perpendicular bisector. All right, just think of what perpendicular and bisector mean. All right, last slide. Sorry, guys. I know it's long. We're in the 18-minute mark. I know it's long. Hang in there. The perpendicular bisector theorem says any point on the perpendicular bisector of a line segment is equidistant from both the endpoints of the line segment. Now, let's think about this for a second. Equidistant means same distance. Okay? So let me make this picture again. Okay, let's make it a line this time. Oops. We'll call that A, we'll call that B, and then oops. We'll call that C, we'll call that D, and then we'll call this middle point E. Okay, so here's my perpendicular bisector. Okay, so line AB. So that line is the perpendicular bisector, of segment CD. All right. So that means that CE is congruent to ED. Now, here's what the perpendicular bisector theorem says. It says if I pick any point on AB, let's say I pick this point, we'll call it F. Okay? So, what that means is F is equidistant. Now remember what equidistant means. Same distance. From the endpoints of the line segment. Well, those are C and D. So here's what that means. If I connected F and C, and if I connected F and D, okay, those would be congruent. So that means that FC is congruent to FD. Okay? Now it says any point. So, what if I pick this point? Okay? We'll call it G. Well, G's on the perpendicular bisector. So, G is equidistant from, again, the endpoints, C and D. So what does that mean? Well, if I connected G and D right there, and I connected C and G right there, that would mean that CG is congruent to GD. Okay? And why not? We're already over 21 minutes, so what's one more? Where are we? What if I pick this point? This might be overkill, but I'm making a point here. We'll call it H. So H is on the perpendicular bisector. So H is equidistant from, well, C and D. So if I connected H and D, and I connected H and C, those would be congruent. So HC would be congruent to HD. Okay? So you get the idea. Any point I pick on that perpendicular bisector is going to be equidistant from the endpoints. All right? That's what perpendicular bisector theorem means. So all the practice problems we're going to do are going to be based off of all of the information I just gave you. Okay? I know it's a long video. We're 22 and a half minutes, and I'm really sorry. But that's a lot of information, and instead of giving you a whole bunch of little videos, I decided to just do one big one. So thank you for tuning in.